Yes, you can use MC cable and terminate it in a non-conductive box if you use a termination nut that permits the cable connector to be connected to the grounding terminal of the receptacle which is mounted in the box. The key to understanding this lies in proper grounding techniques as mandated by electrical codes such as the National Electrical Code, or NEC. MC cable, or metal clad cable, provides a metallic sheath that serves as an equipment grounding conductor, or EG. This metal sheath ensures that if a fault occurs within the cable, the fault current will safely return to the source, tripping the overcurrent protective device such as a circuit breaker or fuse. When using MC cable, the connection of the metallic sheath to a grounding point is crucial for safety. In a typical installation with a metallic box, the MC cable connector makes direct contact with the box, effectively grounding it. The receptacle, in turn, is grounded through its contact with the metallic box via the mounting screws and the grounding pigtail. However, when using a non-conductive box, such as one made of plastic, the grounding path is interrupted. The non-conductive box does not provide a conductive pathway for grounding. This is where the special termination nut comes into play. The termination nut is designed to provide a reliable grounding connection between the MC cable's metallic sheath and the grounding terminal of the receptacle. Here's how it works. Firstly, the MC cable is stripped and inserted into the connector. Secondly, the connector is secured to the non-conductive box. Thirdly, the termination nut, which is part of the connector assembly, has a provision for connecting a grounding wire. Fourthly, this grounding wire is then connected to the grounding terminal of the receptacle. Fifthly, when the receptacle is installed in the box, its grounding terminal is directly connected to the MC cable's metallic sheath, ensuring a continuous grounding path. This method adheres to the NEC requirements for equipment grounding. The NEC specifies that all non-current carrying metal parts of electrical equipment must be grounded. This includes the metallic sheath of MC cable. The grounding path must be continuous and electrically conductive to safely carry fault current. When using a non-conductive box, it is essential to use a listed connector that is specifically designed for grounding the MC cable to the receptacle. These connectors are typically marked or labeled to indicate their grounding capabilities. Several sections of the NEC address grounding requirements. For example, NEC Section 250.4. A5 states that electrical equipment must be installed in a manner that creates a low impedance ground fault current path to facilitate the operation of overcurrent devices. Additionally, NEC Section 250.146 outlines the requirements for connecting the equipment grounding conductor to the receptacle in various situations. In the case of non-conductive boxes, the use of a grounding conductor run with the circuit conductors is often required. This grounding conductor is connected to the grounding terminal of the receptacle and then to the grounding bus in the panel board. This ensures a reliable grounding path, even when using a non-conductive box. When installing MC cable in a non-conductive box, it is crucial to follow the manufacturer's instructions for the connector and termination nut. The instructions will provide specific details on how to properly ground the cable and ensure a reliable connection. It is also important to inspect the installation to verify that the grounding path is continuous and secure. Use a multimeter to test the continuity between the MC cable sheath and the grounding terminal of the receptacle. This will confirm that the grounding connection is properly made. If the continuity test fails, it indicates a problem with the grounding connection that needs to be addressed. Common issues include loose connections, damaged connectors, or improper installation techniques. Addressing these issues is crucial to ensure the safety and proper functioning of the electrical system. Furthermore, it is important to consider the type of MC cable being used. There are different types of MC cable, each with its own specifications and requirements. Some MC cables have an insulated grounding conductor in addition to the metallic sheath. In these cases, the insulated grounding conductor must also be connected to the grounding terminal of the receptacle. Other MC cables may not have an insulated grounding conductor. In these cases, the metallic sheath is the primary means of grounding. When selecting MC cable for a particular application, it is important to choose the appropriate type that meets the NEC requirements and the specific needs of the installation. Additionally, consider the environmental conditions in which the MC cable will be installed. Some environments may require MC cable with special coatings or constructions to protect against corrosion or other hazards. Proper selection and installation of MC cable are essential for ensuring the safety and reliability of the electrical system. When working with electrical systems, it is always important to follow safe work practices. This includes energizing the circuit before working on it, using appropriate personal protective equipment or PPE, such as gloves and safety glasses, and following all applicable electrical codes and regulations. If you are not familiar with electrical work, it is best to consult with a qualified electrician. Working with electricity can be dangerous, and improper installation or repair can lead to serious injury or death. A qualified electrician has the knowledge, skills, and experience to safely and effectively install and maintain electrical systems. They can also ensure that the installation meets all applicable codes and regulations. In summary, using MC cable with a non-conductive box is permissible when a termination knot or connector is used to provide a direct grounding path from the MC cable's metallic sheath to the grounding terminal of the receptacle. This method ensures that the grounding requirements of the NEC are met, providing a safe and reliable electrical system. Always follow the manufacturer's instructions, use appropriate tools and materials, and consult with a qualified electrician if you have any questions or concerns. Remember that electrical safety is paramount. Understanding and following the NEC requirements for grounding is essential for protecting people and property from electrical hazards. Taking the time to properly ground electrical systems can prevent electrical shock, fire, and other serious incidents. By adhering to these principles, you can ensure a safe and reliable electrical installation. In addition to the specific requirements for MC cable and non-conductive boxes, it is also important to consider the overall grounding system of the building or structure. The grounding system must be properly designed and installed to provide a low impedance path for fault current to return to the source. This includes the grounding electrode system, the grounding electrode conductor, and the equipment grounding conductors. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrode conductor connects the grounding electrode system to the main electrical panel. The equipment grounding conductors provide a path for fault current to return to the source from various electrical equipment and devices. The entire grounding system must be properly sized and installed to ensure that it can effectively carry fault current and protect against electrical hazards. Regular inspection and maintenance of the grounding system are also important to ensure that it remains in good working condition. Check for loose connections, corrosion, or other damage that could compromise the effectiveness of the grounding system. Address any issues promptly to maintain the safety and reliability of the electrical system. Furthermore, it's beneficial to discuss the NEC requirements relating to the identification of grounding conductors. Grounding conductors are typically identified by a green color or a green color with one or more yellow stripes. This color coding helps to ensure that grounding conductors are easily identified and that they are not mistakenly used for other purposes. The NEC specifies that the green color must be used exclusively for grounding conductors. Other colors, such as white or gray, are used for neutral conductors, and other colors, such as black or red, are used for ungrounded conductors. This color coding system helps to prevent confusion and ensures that electrical systems are wired correctly. Understanding and following the NEC requirements for color coding is essential for electrical safety. In conclusion, the use of MC cable in conjunction with non-conductive boxes necessitates careful attention to grounding techniques. Employing a termination nut or connector that establishes a direct grounding pathway between the MC cable's metallic sheath and the receptacle's grounding terminal is crucial. This approach not only aligns with the NEC's stringent grounding mandates but also ensures the establishment of a secure and dependable electrical framework. Prioritize adherence to manufacturers' guidelines, utilize appropriate tools and materials, and when uncertainties arise, seek counsel from a certified electrician. Electrical safety remains paramount. A thorough grasp and diligent application of the NEC grounding stipulations are vital for safeguarding individuals and assets from electrical risks. Investing the necessary effort in correctly grounding electrical systems serves as a preventive measure against electrical shocks, fires, and other severe incidents. By upholding these principles, you foster an electrical environment characterized by safety and reliability. In addition to these points, consider voltage drop calculations when installing long runs of MC cable. Voltage drop refers to the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause electrical equipment to malfunction or fail to operate properly. The NEC provides guidelines for voltage drop in branch circuits and feeders. It is important to calculate the voltage drop for each circuit to ensure that it is within an acceptable limit. Factors that affect voltage drop include the length of the conductor, the size of the conductor, and the amount of current flowing through the conductor. Use voltage drop calculators and refer to NEC tables to determine the appropriate conductor size for each circuit. Proper conductor sizing can help to minimize voltage drop and ensure that electrical equipment operates efficiently. Furthermore, be aware of the ampacity of MC cable. Ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The ampacity of MC cable is determined by the size of the conductors, the type of insulation, and the ambient temperature. The NEC provides tables that list the ampacity of various types of conductors. It is important to select MC cable with an ampacity that is sufficient for the load it will be carrying. Overloading the conductor can cause it to overheat, which can lead to insulation damage, fire, and other hazards. Always consult the NEC and the manufacturer's specifications to determine the appropriate ampacity for MC cable. Also, consider the use of anti-short bushings, or redheads, when installing MC cable. Anti-short bushings are small plastic bushings that are installed on the cut ends of MC cable. They help to protect the conductors from abrasion and damage from the sharp edges of the metal sheath. Anti-short bushings are required by the NEC in certain situations. They are particularly important when installing MC cable in areas where the cable may be subject to vibration or movement. Installing anti-short bushings is a simple and inexpensive way to improve the safety and reliability of MC cable installations. Moreover, remember to properly support MC cable. The NEC specifies the maximum spacing between supports for MC cable. Proper support helps to prevent the cable from sagging, which can put stress on the conductors and connections. Support MC cable with cable ties, straps, or other approved supports. Ensure that the supports are securely fastened to the building structure. Following the NEC requirements for cable support is essential for maintaining the integrity of the electrical system. Finally, consider the use of arc fault circuit interrupters, or SIs, when installing circuits with MC cable. SIs are circuit breakers that are designed to detect arc faults. Arc faults are dangerous electrical conditions that can cause fires. The NEC requires the use of SIs in certain locations, such as bedrooms. Installing SIs can provide an additional layer of protection against electrical fires. They are particularly important in older homes where the wiring may be damaged or deteriorated. Upgrading to SIs is a wise investment in electrical safety.